Hello everyone, welcome to my YouTube channel. I'm Kaushik here. So this is actually the continuation of my previous class which was on elementary matrix, and here we kind of showed like how if you have a matrix how we can create a upper triangular matrix from that, and that is basically a Gaussian elimination method, but represent that method into a matrix. So basically, in short, if I recap that lecture, if you have a matrix A, then using the Gaussian elimination method, we can create an upper triangular matrix. We all know that, and those metrics, those steps, actually we can represent as a elementary matrix. The first step was multiply the first row by 2 and then add to the second row. So that was my first step, and that thing actually we are representing into a elementary matrix form. So that's the way we showed that. Okay, we created 3 elementary matrix and finally we got the upper triangular matrix. Okay, now the very important property, like I already covered into the inverse matrix section, that matrix and the corresponding inverse will be an identity matrix. Okay, so that's mean mathematically, if you do the multiplication with this, the inverse of E3, that's mean you'll get a I, which is nothing but the same result. So what does it mean? What will happen if we do the same operation on this? So what we are doing basically, let me write it down one more time. 2 u1 a equal to u, and then we are basically in the first step we are multiplying it by this, and here also we will multiply it. So here also we'll multiply it by E3 inverse of u. Okay, and this mean a identity matrix. So basically it will again bring the same result. So after this step, when we are going to the next step, again it is E2 E1 elementary matrix to E3 minus 1 u, but now again we can multiply it by E2 inverse, and then this will form identity matrix, and in this side also you have to multiply it by E2 inverse. Similarly, so here that's been final step will be something like this. After this operation it is coming like this, and now again we can multiply it by u1 inverse. So finally the final step is telling me, because this will give me identity matrix, and we know that identity matrix, if you multiply identity matrix with any matrix, that will be the same matrix, right? I think I covered, yeah, right, this is the property, this property we are using actually. Okay, so ultimately what is coming, it is coming E3 inverse, E2 inverse, E1 inverse to the upper triangular matrix is basically the representation of that original matrix. Now the question is how we'll find this inverse matrix, and finding the inverse of a elementary matrix is very trivial, very easy actually. How basically we can think about it this way. That's why I clearly wrote this step, so that I can basically now show you what will be the inverse of E1 inverse. So for when we try to build E1, what we did, multiply the first row by 2 and add to the second row. So that's why this is like this. If I have to do the opposite, what do you have to do? You have to multiply the first row by -2 and add to the second row. So that's mean the inverse of elementary matrix will be nothing but this. So clear? That's why I clearly mentioned. So inverse is basically multiplying by -2. So it is the one. Similarly, if I consider E2 inverse, that will be again same thing. So it will be -1, 0 and 1. And E3 inverse will be 1 0 0 0 1 0 0 1 1. Okay, clear up to this? Okay, now now we know what is the elementary matrix and what is the corresponding inverse of that elementary matrix. Okay, so now basically what we are trying to prove, we are trying to prove that okay, A, we know as of now that it is actually E3 minus 1, E2 minus 1, and E1 minus 1 and U. Okay, now again from the mathematical standpoint, multiplying two elementary matrix is very trivial process. So let me just show one thing and then you can easily understand. So if I multiply this two, okay, if I multiply this two, what will be my result actually? So basically what I'm doing, this first row will go by this. So simple multiplication process if I follow, then it will be 1 0 0, and this second element will be again go by this. So it will be -2 1 0, and the third row will go by this. So basically 0 0 -1, yes, -1, and 0 and 1. No, sorry, it should be 0 and 1. Yeah, that's right. Okay, so that's the multiplication. So what if you see properly, this is very interesting actually. Basically when we are multiplying two inverse elementary matrix, what exactly happening, just these values are getting added actually element wise. Okay, so this value and this value is getting into this place along in the identity matrix. So similar way, if we multiply this 3, if we multiply this 3, the matrix which will come, it will be 1 0 0, and then -2 1 0, then -1 1 and 1. This one is coming from here. Okay, very simple, very easy. Just try to understand. It's a very simple way you can do the multiplication of inverse elementary matrix. Okay, so now if you see this thing, this is actually a lower matrix, lower triangular matrix. Okay, I don't want to I hope I have not messed up the number, right? Let me probably just use a different color. So this is one, this is one, this is one, this is two, and this is two. So basically I'm trying to say that okay, this is forming a lower triangular form. So that's mean now A can be represented as a lower triangular matrix and upper triangular matrix, and this is called the LU decomposition of any matrix. And this is very important, like when we'll go into the further classes, you'll understand that this is so important to understand this concept actually. Hope you like this video. If you're following my metric sessions, please support me, give me a thumbs up or subscribe my channel. Your support will help me to grow. Thank you so much. See you in the next video.